think we've got everybody up. Ed, I'm going to make you the presenter. Al, I've given you voice as well.
Okay, so Rich, I guess we didn't talk about it, but do you want to do any introduction before we start?
Yeah, I'll do that in just a moment.
Okay.
Apologize to everybody online. We had a couple of snafus. Something did not connect down here. I think we're now good, thanks to the IT staff. Let's see. There you are, Ed. Okay, Ed, you are now presenter.
Okay, can you all see me?
Yep, and then whenever you want to pass it off to someone, let me know, and I will make them the presenter.
Okay.
Everyone.
I'm sorry, just checking. Do you see the single screen, or do you see a couple slides?
Right now, I see a single screen.
Okay. This is the total of my presentation.
I like it.
One page, huh? Should we check and make sure everybody's online?
Yep, right now we have 37 people and climbing. We'll start at about 11:05. I want to give everyone a chance to get in. I know we had 6 or 7 actually registrations from a number of people who will be introducing themselves from NOAA staff. We have about 70 registrants today. I want to thank you all for taking time to come to this. I certainly, in the wake of what has gone on in Oklahoma and in Hurricane Sandy as well, for those of us in New York, I think we're all aware of the devastating effects of weather and climate that are coming here. My name is, again, Richard Quotema. I'm New York State Department of Transportation and New York State GIS Association's Professional Development Committee Chair. We are very pleased to have NOAA here. And I also wanted to give a very special recognition. We have a number of people here from Oklahoma that have called in. Hopefully they can also derive some of this. We are, of course, very cognizant of the tragedies that have surrounded from that apparently Class F5 tornado that touched down near Moore, which is just south of Oklahoma City, as I understand it. On a personal note, I heard back from my cousin yesterday that she's safe, but she lives in Oklahoma, and I wanted to say that all of us in New York State here from the New York State GIS Association, where I am at New York State DOT, our thoughts and best wishes to you as you recover, and what we can do to support you from here, we'll be happy to do so. So without further ado, from NOAA here, Mr. Ed Levine, the Scientific Support Coordinator. Go ahead and take it away, Ed.
Excuse me. Thank you, Rich. Really wanted to extend a thank you to Al for suggesting and requesting this, and you for organizing it, and the New York State GIS Association for being interested in hearing about the NOAA products and services. The quick background. Oh, I also wanted to, mention about hopefully a speedy recovery out to the Oklahoma folks. Just to give a quick background on how I got involved, my position is the NOAA Scientific Support Coordinator, and this role is delegated through the National Contingency Plan. It basically states that NOAA shall provide the U.S. Coast Guard scientific support. The way I describe it, so my mother understands, I'm the Mr. Spock to Captain Kirk. So we help advise on scientific issues for emergency response purposes, but Beyond that, we also act as a NOAA liaison in the area. My specific area of response is Connecticut to Delaware. During the Sandy incident, we were very busy, but we were casting a lot of information through AL and out into the GIS world and the DHS connections. NOAA has a lot of products and services that are vital to predicting and responding. Our office is the Office of Response and Restoration. We specifically focus on response to emergencies, restoration after an emergency from the environmental point of view, and then also we have part of our department is the Marine Debris Program that, again, post-Sandy and during the Japanese tsunami actually had fairly large response roles, which was something they haven't been normally used to doing. So I'm going to stop here because I want the folks that are going to be actually talking more about products and services to have as much time as possible to present to you. So I'm going to just quickly mention, or put up the agenda. So we'll following the introductions, we'll have Mark Miller, Glenn Watabayashi, and Kerry Sheets from the Office of Response and Restoration, Darren Wright from the Center for Operational Oceanographic Products and Services. Adam and Doug's going to tag team from the Coastal Services Center. Gary Conti with the National Weather Service. It's Brent Pounds from the Office of Coast Survey, and John Sellers will wind up with the photogrammetry. And I hear the mower in the background, so I'm going to turn it over to you, Rich.
Okay, that sounds good. Mark, if you're ready, I'm going to go ahead and make you the presenter, and we'll go from there.
Great. I'm ready, Rich.
And should be flipping over to your screen as we speak.
Okay, I hope everybody can see the first slide of the presentation. My topic today, we're talking about the air dispersion model capabilities that we've developed within the Emergency Response Division. And again, I'm based out of Seattle, Washington. That's where actually the main portion of our group is located. And I lead the development group, so all the software that I demonstrate today are things that we developed in-house. I do want to take an aside is that our products are actively involved in the response in Oklahoma. Again, I agree with everyone's comments that our concerns and thoughts are with you. We have a contact who manages all the emergency response EHS data in Oklahoma State, Tom Bergman, who works for the Department of Environmental Quality, and he has been actively responding using our mapping components as well as the information he has in Cameo I'm going to talk about. So the presentation's on Aloha. I'm going to give a very quick overview of Aloha, and then at the very end, I have no slides, but I'll talk a little bit about our interactions with the IMAC. So Aloha, what is Aloha? Aloha is a component of what we call our Cameo suite. It contains a chemical database with over 5,000 hazardous chemicals, information on 5,000 hazardous chemicals. It allows you to mix chemicals. If you have an accident that involves multiple chemicals, you can look at potential reactivity issues with that. As I mentioned, Aloha is the air dispersion model, and I'll go into more detail in the later screens. We have a mapping component that's integrated with this, MARPLOT. An aside also is that MARPLOT's undergoing a complete rewrite, and will be out within the next 6 months with a significant increase in capabilities associated with its ability to see imagery as well as our product information. We have the next component is the Cameo FM. That is the database that stores the EPA's EPCRA data, the Emergency Planning Community Right to Know Act data. So facilities are required to report the hazardous chemicals that are stored in their area, stored at their facility, and that information is managed typically on a state or local basis, and that's the databases that store that. And then the last component, the Tier 2 submit, is an electronic support reporting system for facilities to do that annual reporting requirements. Aloha is a particular air dispersion model that meets the needs of the vast majority of the incidents, the chemical incidents that we are responding to. It has a couple different models, not to get into too great detail. The heavy gas dispersion allows you to model gases that are refrigerated or heavier than air, such that in the near field, in close to the release, that gas will actually be heavier than the atmosphere and follow the ground level, and Aloha is designed to take that into account. It is specifically a short duration, 60-minute release, short range, maximum 10 kilometers. So it's fundamentally best used as a scaling model. Again, when we respond, and again, Ed is the pointy end of our spear, when we're responding to an incident with the Coast Guard, one of the first pieces of information that we try to provide them is a scale of the incident. Is this a tens of yards, a hundreds of yards, or thousands of yards kind of incident? That allows you to scale your response appropriately. One of the things Aloha has that's very useful is it has time-dependent chemical source models. The biggest area of unknown uncertainty associated with any airborne release is going to be the amount of chemical that has entered the atmosphere. Aloha helps you do that for pressurized tanks or evaporating puddles, gas pipelines. Those are source models built into Aloha that feeds into the model. Relatively recently, the last couple of years, we upgraded Aloha to include threats associated with fires, pool fires, as well as levees, as well as flares coming from pipes or tanks, as well as explosion models, vapor cloud explosions, and that sort of thing. So Aloha contains all that information. Who uses Aloha? This is somewhat dated information, 2006, but I think the percentages, vast majority of people probably fall into the first responder realm. Another very large group falls into the emergency planning component. That's like the contact in Oklahoma, Tom Bergman, is in the emergency planning phase of it. We also have industry as well as academics and other NGO type of organizations that deal with Aloha. Aloha is freely downloadable off the internet. It's downloaded on the order of 1,000 to 4,000 times per month, and that's been going on for almost a decade. This is just a table that shows the scenarios that Aloha can handle, toxic scenarios, fire scenarios, and explosion scenarios. I'm not going to read all that information. One of the things is Aloha is built to work completely with the MARPLOT mapping program that's integrated into the Cameo suite. But in addition to that, we realize that a lot of other people want to be able to use that same information. So we have developed ArcMap tools. I've provided the link here, but again, the easiest thing to do is go onto our website, which is that first part, the response.restoration.noaa.gov, and then you can search for the Aloha ArcMap tools and get the download part of that. Aloha is also built into it. It can export its information as a KML so that you can then display the information in Google Earth. This is just an example of output from another model that we've integrated with, but in a very similar way. This is in Google Maps. So one of the things I thought I would mention, we are trying to continue to enhance our products. We upgrade the software pretty regularly. We're in the midst that has been slowed down somewhat by the budgetary issues that we're struggling with in the federal government right now. But we're trying to move Aloha to the web portion. Again, I think everybody on the phone could probably appreciate the fact that we want to move a product that is state-of-the-art 1995 to something that's a more 2012 kind of technology. There's a huge demand for access to, of our information on mobile devices. We do have a mobile optimized version of the Cameo Chemicals website. That's the database of hazardous chemicals, and you can access that relatively easily from your smartphones or tablets. And then in addition, as I mentioned in that display that we had on the Google Maps, we are integrating Aloha's components. Right now we've integrated for the weather service, optimized for the weather service, is integrate the Aloha source strength models with another model that Aloha has, which is called High Split, developed in another portion of Aloha. But that moving to the web allows us to take that technology and make that a little bit easier. I want to pause a moment. Does anybody have any questions, or are we taking questions, Rich, before I talk about our interaction with IMAC?
There should be down below. There should be a sort of a questions. I see it come up as a. I see it come up as sort of a questions panel. But on your screen, you'll see the opportunity to do a raise hand or do a question.
Okay.
Go ahead and use that. That's the best way to do it. And there's also a chat box where you can type a message as well. You can direct that to someone, or you can direct it to the audience, or you can direct that to me. I'll get that, and we'll go from there.
Okay. Why don't I just start talking about the IMAC? I will ask people to raise their hand to know who actually knows what the IMAC is.
Sorry, Mark.
Yes.
Just on my interface, I can't get into the chat to type a question, so I don't know if I'm the only one or there's an issue.
I'm not familiar with that either. Well, Rich, if you have an answer for that, I'll continue talking about the IMAC. I guess if Rich can get any questions, he can filter them back to me, or obviously we're available through Ed Levine for any questions you have. The IMAC stands for Interagency Modeling and Atmospheric Assessment Center. It was created about 10 years ago following a drill in which multiple federal agencies were providing modeling support, and it was confusing to the local authorities. And so Department of Homeland Security, through Homeland Security Presidential Directive 5, I think, HSPD 5, created the IMAC, which means that in an incident that is significant enough, oh, I got something flashed up on the screen. In an incident that's significant enough that multiple federal agencies are providing support, then the IMAC is activated, and a coordinating agency. So presently the IMAC is run by the Defense Threat Reduction Agency, DTRA, which is part of the Department of Defense. But the idea is that the whole goal of the IMAC is to coordinate the activities of all the federal agencies providing modeling support, so that the incident commander or the decision makers have a single point that they can go to for technical reachback. And it makes a lot of sense. It's pretty challenging in real life, but it makes a lot of sense. It's interesting, we just met last week with the DTRA IMAC organization, and we're trying to coordinate our activities. In particular, as I mentioned, the largest area of uncertainty with any modeling incident is trying to estimate the source, and that's a real challenge. And it's usually useful to have a dialogue on that, where we kind of compare notes and make sure that everybody's using the same source strength, so that you can compare answers a little bit more effectively. So we're moving forward with that, and it's a pretty exciting kind of activity. I'm all done, Rich. If we don't have any questions or anything, we're ready to move on to the next speaker.
All right, let me check here. I've got some audio quite, but nothing from that. And no, not at this time, but like I said, we can always have questions. I'm going to flip it back over to Ed, and then he can, the next person, hold on one second.
I think that's Glenn Watabayashi.
Oh, all right. And Glenn, hold on one sec. I'll make Glenn the presenter.
Yeah, and Rich, you could just switch it to Glenn.
Yep. Done and done. Coming up now. Glenn, you're on.
Yeah, I think we're missing his audio.
Oh, let me check his attendee list here, but his screen came up. Glenn, are you still with us? I don't see him on the attendee list all of a sudden. Wonder if he had a technical snafu.
Do you want to go to who's next and then let him get himself on?
Mark, are you in the same building with Glenn?
I'm going to go check on that right now.
Okay,
Yeah, Glenn's up, and oh, I see. He probably didn't enter his PIN.
Okay, if we
I
continue.
sent him a reminder of the PIN.
Okay. If he doesn't get on in a minute, maybe we can move to Kerry and come back to Glenn.
Okay. Make Carrie a panelist here.
It looks like Kerry's ready to go. Why don't we switch
Hold
to her?
on one second. I think Glenn just entered his PIN.
Oh, there he goes. Very good. Thank you.
Glenn's still self-muted. Glenn, you may have the mute on your actual phone.
Just click on the phone icon and say unmute or take off mute.
He's not muted on my end. He's muted on his own end.
Okay.
Where did that happen?
You were unmuted.
Where did that happen?
Okay, there we go, Glenn.
How
Now
did
you're
that
coming.
happen? My phone wasn't on mute. Okay, nonetheless.
That was weird. But go ahead. We're all here.
Okay, so let me start. Quick go through on our ocean modeling. You know what we bring to the table. So just the first picture is that's me in the back with the big hat. You know, this is we've been doing this a long time, and like Mark said, you know, all of our software is homegrown because that's the way we started. There was nothing out there. So our software is all out there. It is free for the download on the internet. You know, go to our website. So what do we bring to the table? What happens when Eddie calls us? So, you know, the first thing we do is we scale the problem. Basically, we have our mental model of the issue and how big a deal it is. Then within the first hour, you know, we write something out. We write something out and we say, okay, this is a big deal, this is not a big deal, and that goes out verbally, and we write something up. And then if it is a big deal, then, you know, we start gearing up our modeling tools. We'll send out teams into the field, and then we start doing our forecasting. Then, you know, we've been doing this since that photograph, actually since the 70s, and the tools have continued to evolve. What do we tell people? We tell people where stuff is going. We tell people when it's going to get there. We tell people how much they can expect, and what it's going to look like. You know, are you going to have something that you can clean up or not? And we get about 150 to 200 calls a year. Most of them are little events. Some of them are mega events like Deepwater Horizon. We get about maybe 100 to 125 calls for oil, and then we get a bunch of calls for chemicals, and we have a bunch of odd calls, marine debris or search and rescue calls. And this is our tool. GNOME is the tool that we use. This is something that we maintain and we upgrade. It's getting a major rewrite right now. The next version will be a web app. You can go to our website. You can download this. It's free. We have a lot of users around the world. There's a little bit of documentation, not a whole lot, but it's pretty easy to use. Here's an example. You know, I think one of the key things for our tools are that they're not location specific, because we don't know when we, you know, where the next call is going to come from and how big a scale it's going to be. So this is an example of a large-scale event, right? This is the tsunami debris that's come across the Pacific Ocean, and we've been tracking this stuff for, you know, about 2 years now. So there's a large-scale example. We can get currents from the Navy and from NOAA, winds from NOAA. You know, we can get input data from several sources. Here's an example of a much smaller scale. Same model, different input, totally different scale. So this is an oil spill that resulted from Hurricane Sandy. You know, once again, same model. It takes about what is this? Okay, so you know, it takes about maybe half an hour, 45 minutes to put this together and get a run done. Then here's another example of something that we put out for, you know, we put out for a large pollutant event that's going to go on for a while, that's got high visibility. We put out some nice output that can go up to the White House or briefings or get shown on CNN or whatever. You know, the way it works for the output side is that we put out basically a distribution of particles out of GNOME, and that gets post-processed into contours that can go into the ArcGIS products or into to the Google Earth family of stuff. So right now everything is post-processed to get it into another GIS system. The next version of the model will put out automatically KMLs and shapefiles, because we know that's what everybody wants to view them in. So, you know, we're moving on that. You know, this product you see now, it took us about 2 to 3 hours every day to put this set out, because we would get inputs from overflights. We could input satellite observations into the model, you know, and then the model gets rerun with multiple inputs, and then we have to do our analysis on it to come up with the picture. But it was a long summer. Okay, key points. So now can be quickly, easily used, different time scales, different length scales. Very flexible. We need it that way. You know, be brought up quickly. It works on Windows. It works on the Mac. Next version will be a web app. So, you know, it should work on a tablet. Then it takes us here, you know, 2 to 4 hours to bring it up for anywhere. 4 hours if it's someplace we haven't worked before, like someplace out of country. You know, more like 2 hours if it's someplace that we're familiar with and we've worked with before. You know, think about how we would be able to do this back in the 70s and early 80s when we were still on computer cards and 300 baud terminals. That was a challenge, a real challenge. Okay, so something I just want to put up the screen. For inputs, you know, we've developed an online data server, and you're looking at it. Once again, this is also free to the public, this website. You can get on this, and it'll put out ocean currents. It'll put out observations for currents. It has winds, sources for winds. Global, North America, you can have, you know, wind observations. You can have tap into the Weather Service's point-click forecast. And we also have maps for GNOME. This is shoreline maps of the world. So very flexible. You know, it's a limited set because you can't get currents at every resolution everywhere. So we have our own in-house tools to develop currents, you know, if you can't get it here. But This is kind of cool. You know, our users around the world have really taken to this tool. Comes at the right price. Let's see. So other things, ability to initialize. So we can do different types of sources, right? We can do a moving source for pollutant. We can do time-dependent sources. We can initialize from overflight, satellite obs. We can fold in oil fate, for that matter, pollutant fate information, you know, that's available. Outputs will be, you know, we can generate QuickTime movies. You know, we can export particles to post-processing, like I mentioned before. And then we can specify uncertainty. For us, this is a big deal. You know, models are models. They're not God's truth. So, you know, there's the ability to specify uncertainty in the inputs, and that gets reflected in uncertainty in the output. And then, you know, after that, it's up to the decision maker to figure out how they're going to use the uncertainty. Another example, you know, something that we've been working on for the last few years, we can do 3D outputs. So, you know, we get called for chemicals in the water. Everybody wants to know what's going to get hurt, or is something going to get hurt. So you need to know concentration and exposure time, and you need toxicity information. So there's, you know, the GNOME is able to put out concentration as a function of time, and we have another database for chemical toxicity, aquatic chemical toxicity, that we use as in-house too, and I'm sure it's going to become publicly available in the near future. So, you know, it's another tool in our suite of tools. So chemicals, it'll do chemicals in the water. So the last two slides, planning. You know, we do quite a bit of planning type modeling, and planning is a whole different story, right? Because you don't know when it's going to happen, you don't know how it's going to happen, you don't know how much stuff's going to be spilled. So, you know, one of the separate tools that we've developed is called PAP, the Trajectory Analysis Planner. And what it does is it runs scenarios. It runs thousands and thousands and thousands of GNOME scenarios under different conditions. And then it puts together probabilities from all of the runs. And this is an example. A separate way of looking at output, right? So what you're looking at here is our potential oil drilling sites off of Cuba, and the question is, okay, if you got a large oil spill off of Cuba, where could they all go? And so you do thousands of runs, you put together the statistics, and then you come out with probabilities. So this is another type of output that we have generated using GNOME and the rest of our modeling tools. You know, this was about a 3-month effort for us. Okay, so that's it. That's my last slide. That's my 10 minutes of fame here. You know, I can just say that the tools are available for free online. They are, you know, aquatic tools. We've used them in rivers, large rivers, Mississippi, Columbia River, smaller rivers like Kalamazoo. You know, we have goods that'll give you currents and winds. It taps into all of the NOAA co-ops models. So, you know, we have currents for not only the coastal areas, but for the Great Lakes. You know, so it's there. It's all free. And if you have questions, you can come back to us. You can go through Eddie. We have a support group through the web. You can ping us through our web interface, and we'll get somebody to answer that. That's it. I'm done.
Hey, Glenn, you got a couple questions.
Okay.
What is the website URL that you've been referring to?
It's the same site that Mark Miller put up. You can go to our, you know, you can Google NOAA, NOS, ORNR, and you'll get to our website. And if you type in the search, you type in GNOME, G-N-O-M-E, it will come up.
Okay. So GNOME.
I could, Eddie can pass that on. He's got it.
Okay. And this probably to the broader group of NOAA. Is there going to be better integration with Esri ArcGIS type products such as file geodatabases?
Like I said, the next version. Right now, you got to download tools from our website to translate our output into shapefiles, MLs. Right. The next version of GNOME will do that much better. So we are going to put out quicker, easier ways to put things out. One of the things that we struggle with, though, with the Esri tools, there are two things. One is that it doesn't do well with 3D output, and the other thing is that it's a struggle when you got to do time-dependent output, which is the case for us, right? Because the pollutant's always moving. It's not static. It's not like this is data that's static, geographically. It's something that kind of like a movie, right? It changes, every hour, every 2 hours. But yeah, we're going to put out shapefiles much more easily in the future.
That's also a very good point about moving, moving in real time and that sort of live simulation. So thanks. That's a good point. Maybe Esri, if they're on the call, can pick up the phone with you and get with that. I believe one of the members of Esri did, one of the employees at Esri did register, so maybe the two of you could talk offline. Okay. Sure. Thank you, Glenn. I appreciate it. If I'm not mistaken, Carrie, you're next on.
Yes.
All right. We're switching over to Carrie.
Okay, can you see my screen now?
Yes.
Okay. So I also work for the Office of Response and Restoration in a separate division from Mark and Ed and Glenn, which is the Assessment and Restoration Division, and I'm specifically in the Spatial Data branch. And even though we're in Assessment and Restoration, we kind of touch on a little bit of everything that ORNR does, which is also the emergency response, which you've heard a bit about already, and then marine debris as well. And so specifically, the tool that I'm talking about this morning is the Environmental Response Management Application, or IRMA. And this is a regional application. So the screenshot you see here is for the Atlantic area, and we were used in the pollution part of the response for Hurricane Sandy. Okay. So what is IRMA? It's an online mapping tool for visualizing environmental information, specifically focused on big events, disasters that affect the environment, from oil spills, hurricanes, release of hazardous materials. Our biggest endeavor so far has been the Deepwater Horizon response, and actually a lot of our office is still working on that from the restoration side of things. So we actually split out a separate application for that event because it was so large and had such a high interest from the public, and that was what we call the IRMA Gulf Response page, which is the screenshot that you see here. So where is IRMA? Pretty much all around the coast. Right now we don't have much in the southeast, on the Atlantic coast, the Carolinas and Georgia, but we're pretty much covered everywhere else. The Great Lakes is coming up, hopefully by the end of this year. So IRMA in action, the picture here of IRMA being used in a Coast Guard briefing. The main idea here is that it has centralized access. It is available via web browser, so pretty much anywhere you can have the internet, you can have IRMA. We actually are also working on standalone IRMA, primarily for the Arctic and the Caribbean areas where where the internet isn't as reliable, but we know that it'll also come into play post-disasters when infrastructure has been destroyed and you need to be able to just stand something up without having the internet connections. But the idea then being that it doesn't matter where your team is, everybody can look at the same map, and you can look at it independently, or you could do something like a WebEx to be able to look at it together. So basically, it also has 2 layers, and I'll talk a little bit about that in a moment, which is when you just go to the URL, you get the public information, or you can log in. But no matter who else logged in, you control your screen independently, so you're not seeing what other people are doing. But if they were to add data, that data would become available to you. We also have some basic abilities to analyze, as well as being able to just see the data on your screen. So again, the uses for IRMA, talked a bit already about visualizing the situation, also to assess the damage and plan for restoration. So where do we already have projects maybe related to other incidents? Where was there oiling? What were we put the environmental sensitivity indexes in, so you can see what is of most concern. To create a common operational picture, so that's what I was talking a little bit about, so that all of the decision makers can see what's going on when and make the decisions that they need to make, as well as analyzing threats from climate change, drilling, and hurricanes. So for those of you that are familiar with the ICS structure, just threw this slide in to show where IRMA would sit if you were actually in an incident, and that's usually in the data management GIS processing area, or sometimes we sit within the environmental unit because that's where most of the NOAA efforts are usually situated. So IRMA is an open source stack. We went that way for several reasons, but we are interoperable with things like Esri. So this just kind of shows what the guts are. I won't dwell on it, but if you have questions later, you'll be able to contact me about that. But the main pieces are Postgres, PostGIS database through map server, and then the actual screen that you see is an open layers interface. So our key functionality, I've already mentioned it, the web browser, you don't have to download anything. You just hit the URL and you're good to go. I will say that we only support the most recent iterations of the browser. So if you're running something like Internet Explorer 5, you might encounter some issues. We have a tiered system security, so that's for protecting the data. That's what I meant when I talked about us having a login versus the public. So when there's things like trustee data or data that's proprietary, we work out with data agreements with the parties involved in an incident and set the appropriate levels of protection on the data. We also have the standardized user interface, so if you were to need to go to a different region, even though it would be a different URL, it's going to look the same. And so it's especially helpful for us within NOAA that our leadership knows what they're going to see no matter where the incident is. And we also are able to build maps and export them as PDFs to use and share, or you can share a customized URL with those layers so that you can quickly let other people know what you're talking about. So how can IRMA help you? Well, I've already touched on data collection, visualization, and sharing. Natural resource information, key information we try to always have available are sensitive habitats, species distribution, the endangered species identification. We've even worked some with Fish and Wildlife Service so that we can export or jump from IRMA to their tool to look at some of their species and protection plans, resource and risk reporting, and restoration planning. Critical infrastructure, always try to get in the railroad lines. If it's something like Hurricane Sandy, we also try to get the evacuation routes in. Critical facilities and hazards information. And those are all things that we can work together as partners to make sure in in the planning phase for an event so that we're not scrambling for that when an event happens. And I already mentioned the environmental sensitivity indexes as well. We also get the area contingency plans and the geographic response plans. So this is, we already saw this again, but part of the reason for the open source stack is that it allows us to do more queries in some of the standard web interfaces, and that's because of the Postgres and PostGIS database allows for the data querying and summaries. So the interactive tools are some of the basic things you would see also in things like Esri tools. If you're more familiar with like FlexViewer, which is their web-based tool, you can still zoom, you can bookmark map view. So we've got it set to where you can, when you log in, you can create something and then set your own little bookmark that shows up at the bottom of your table of contents. Typical other GIS tools like measurement tools. Animations works more like a slideshow than something you would see on like where you have a play and a pause button. We always make sure that we have metadata access, at least light metadata for responder data, but for anything that goes public, we have the full either FGDC or ISO metadata. We do attachments. So Glenn presented the trajectories like from deep water. We would load those in so you could see them on the map in IRMA, but we'd also attach the actual file like what you saw in his slideshow. Find tool to allow, because for example, for deep water we have over 16,000 layers. Well, nobody's going to know where everything is. So there's a bar at the top that you can search just like you would search the internet for anything else. Also the ability to print and several querying tools. I mentioned already we have interoperability with proprietary formats. So this is the Weather Service's just standard weather map, which was provided to us as an ArcMap REST service. That's one of our more recent additions. Sorry, my computer's freezing on me. And then we also are working on automated data pushes. So far we've only done this internally, but what you see here is we actually have another application that does data management for deep water, and when someone does a query, they can automatically select within that application to push the data to ARMA. And so that's one of our goals for something to come, is to be able to accept data. We have to work through all the security pieces to that, but from other applications, just like we push, I mentioned earlier, we push to the Fish and Wildlife Service tool. We want to allow other applications to push to us. So the benefits of us being open source is that we can make sure that we're interoperable with many different things. Another project by one of the other offices within the Ocean Service was to do an open source hosting. So I know someone asked earlier about being more interoperable with GIS, with standard GISs. So this is still another open source project, but it's an attempt from NOAA for you to be able to get at more of our data as a web service, which can be pulled into something like ArcMap or QGIS or whatever application you happen to be using. This is an example of one of the services that they have hosted, and it's the track from Hurricane Sandy, showing when it was a tropical storm to a hurricane to when it moved to being extratropical. And that's all I have. There's my contact information and the URLs for the Atlantic version of ARMA.
Okay, Carrie, thank you very much. Appreciate it. Hope everyone got a look at her website up there. And let's see. Ed, who's next on the...
Darren.
Darren, all right. Excellent. Okay. Darren, you're now presenter, so as soon as your screen comes up, feel free to take it away. We are now seeing a ports slide.
Excellent.
All right. Fire away, my friend.
Unfortunately, that wasn't my first slide, so let me back up. There we go. Okay, again, my name's Darren Wright, the Maritime Services Program Manager for the Center for Operational Oceanographic Products and Services, a mouthful. And as Ed said, the grandmother version is we are the tides and currents part of NOAA. And you know, being a Fed, us Feds love our acronyms as you've seen so far, and I'm going to introduce another one. It's called PORTS. And what that is a physical oceanographic real-time system. So what I'm going to be talking about is some of the real-time observations that you can look at during storm events. But before we get to that, just a little more background on what we do at what I'm going to call as co-ops from here on out. Is we have a national water level observation network we call the NOAA. As you can see the United States plot there, we have over 210 permanent long-term tide stations or water level stations. Associated with most of those, we have meteorological sensors like wind speed and direction, barometric pressure, air and water temperature, and conductivity. But we also, from that network and from historic installations, we are responsible for the tide predictions as well. So we put out the tide and tidal current prediction tables every year. We also do, we're also responsible for, as I mentioned, tidal currents in the tidal current prediction tables. So we go around and do short-term current deployment. So we can do surveys. So we can update tidal current predictions. Co-ops is involved with all these different various activities, and I have 15 minutes, so obviously not going to be able to cover all of these. So I'm going to focus on these four for this discussion. And we'll start off with PORTS. PORTS is basically a network of physical oceanographic systems such as water level, currents, waves, and we have meteorological sensors like you know, as I mentioned before, wind speed and direction, barometric pressure, air temperature. We also have a visibility sensor that we can determine, you know, visibility during fog situations. And we also have a sensor, it's called an air gap sensor, that actually measures the distance between the bottom of the bridge and the surface of the water. So this is becoming more and more important as vessels are getting larger and larger. So what does PORTS provide? It provides accurate real-time information to help improve safety by avoiding groundings. By knowing exactly what the water level is, you have a much better chance of avoiding a grounding. Safer vessel maneuvers. If you know what the currents are doing, that'll help you move your vessel safer. Efficiency of maritime commerce. If you have an extended high water event, you can, you know, the possibility of increasing cargo and reduce delays. If typically you have to take a vessel out during high tide, but you have a high water event, you might be able to get a vessel out sooner. Improve search and rescue. If you know what the currents are doing, you have a much better idea where a stranded vessel may go. Environmental protection and planning assistance. Improved hazardous material response. We have several current meters down in the Gulf during deep water horizon. That information was sent to ORNR to help in their trajectory models. This information can also be used for restoration projects. Recreational boaters and fishermen use this information. Down in Tampa, one of our biggest users of the port system are the windsurfers. You know, they want to know what the winds are doing. Improve forecasts. All the data that we collect, we provide to the National Weather Service for to improve their forecasts. We also provide our water level information to the Hurricane Center for their storm surge models. And this information can also be used for, you know, for teaching oceanography in school or for doing research as well. Now, ports, unlike the NLAN or the National Water Level Network I mentioned before, where NOAA is fully funded for that program, ports is a partnership program where we're funded for the program management, the data collection, infrastructure, data dissemination over the web and phone, which I'll show you in a minute. We have a 24/7 quality control group who's monitoring the data constantly, national standards, and future enhancements. What the ports program is not funded for is the local equipment that's installed in a particular port area, and I'll show you an example of that. So we need to find a local partner to help fund the equipment, the installation of that equipment, and the annual operation and maintenance. So here's the New York, New Jersey Harbor Ports system. It's a network, as you can see, of various different types of sensors. And another difference between the National Water Level Network and this port system is that the local community helps determine where we install these sensors. So in addition to New York, we have 21 other operational systems. Charleston on this plot just came online this week, so we now have 22 operational ports around the country. So what does ports provide? Predicted and observed water levels and currents, meteorological information, as I mentioned, bridge air gap, water density, salinity, and waves. We provide all this information over the web in graphic format and text format and through a voice system. All our data is updated every 6 minutes, and all data is quality controlled 24/7. So if any bad data starts being disseminated, it gets shut off until it's fixed. As I mentioned, each individual port system gets their own phone number, so you can dial up the system and get the information over the phone. And I need to update my graphic; it's a little dated. We also provide graphics in the upper left here. You see this blue line is the tide prediction, and this is typically what it would be on a calm day. But obviously we have some meteorological things going on here it's forcing the water out of this bay here in Sabine, Texas, and you actually have less water than you're expecting if you're just looking at tide prediction. So this is the real value of real-time data. This is a recipe for a grounding if you have less water than you're expecting. We also provide some current information, a little chartlet here. A little bit difficult to see, but there's some arrows here that show you what direction and what the velocity of the currents are doing. And then down here we have some meteorological information. This is a product that's called MyPorts, and it's a way if the graphic I just showed before is kind of a canned graphic that we give you, but this product gives you the ability to build a page however you want. So if you're not interested in some meteorological information, only water levels, and you can build yourself a water level page. And once you've built the page the way you want it, you just say save and bookmark that, and you can send that out to whoever you want, and you can build as many of these pages as you want. It's kind of a neat product. We also have an automated real-time narrative summary. Basically takes all the digital data and gives you a text summary of what's going on in the region. We also have a mobile app that takes the text data from the internet and kind of reformats it for your phone. But in addition to the real-time data, we also have a hydrodynamic model. We don't offer this in all the ports locations, but we're working on that. But basically, it gives a nowcast and a forecast of what's going on. This is kind of hard to see because I just grabbed this this morning because it's a nice calm day up in New York. But there's a dashed black line in there. That's the nowcast, which is a model run basically explaining what's going on right now. The red line is the observed data. This green line here is what the model is forecasting the water level to be. And then the blue line is the tide prediction. So if you have a meteorological event going on, you'll see some separation between the blue line, which is the predicted, and what you're seeing for the observed and for the forecast. This is on the right is the model that we run in New York and the locations where you can get information. And then in the bottom, the left here is one of the regional outputs that it's actually an animation that you can see on the website. It shows you what the water level is going to do at certain times in the future. And as we mentioned, the National Water Level Observation Network, we have tide gauges all around the country, and where this is valuable is during storm events. All that data is sent to the National Weather Service for their forecast models, the meteorological information, and the water level information is sent to the Hurricane Center for their slosh model and storm surge model. This is from some historic hurricanes, but you can see the blue line here is the tide prediction, what you'd expect, and then the red line here is the observed during a major storm event, and the green line here is the difference between that tide prediction and the observed, which gives you an idea what the storm tide is during that event. We also have a product, and I'm getting away from ports now to some of our other products that you can use during storm events. We have a product called Quick Look, which is a product we put together during major storm events, where we use the National Hurricane Center's plot to kind of show you where the storm is headed, and then what we do is plot up all of our water level stations that are being affected by that storm, and we just kind of list them down the page. There's an example here on the left of during Sandy, and we just list all the stations that are being affected by the storm, and you can see what's going on right now. So it's a real-time snapshot of what's going on. And during storm events on our main webpage, which is tidesandcurrents.noaa.gov, we'll highlight a major storm that you can click on right from our home page and get to this information. And again, all this information is updated every 6 minutes. All right, this last part I want to talk about is there was a bit of a communication issue on datums during the Sandy event, and I could spend an hour trying to explain datums, which I'm not going to do, but I just wanted to quickly say that we're working with the National Weather Service to get our messaging clear so everyone has an understanding of what's going on. We put our data out what's reference to what's called mean lower low water. It's basically the average of the lowest tide, and we use that datum because that's what's on the nautical charts. So that's what this is referencing. So here's the tide prediction during Sandy at the battery, and here's the observed data, and you can see it's up at 14 feet. But that's a little deceiving because it's based on what the lowest low tide is. But we also have other datums like mean sea level, which is the average of what the sea level is, and then we have another datum called mean higher high water, which is the averages of the highest tides. So depending on what datum you reference, the storm tide is going to be a little bit different. So most people are familiar with what mean sea level is, which is what the sea level normally is. So we saw a storm tide, which I'll explain in 1 second, of 11 feet. But what people really care about is what was the surge relative to ground level where I'm at. And that was actually just about 5 feet during Sandy. So here's a little bit of an explanation of what storm tide is. So we're going to use mean sea level as the reference. This little section here is called the predicted tide. So above the mean sea level, we had a predicted tide of 2.1 feet at the time of the biggest surge. And also during that time, there was actually an anomaly in the tide of about a foot that was above the predicted tide, and that could have been due to various other events. But at the time, the tide was almost a foot above what the normal predicted tide was. And then when the storm hit, everything above that is the actual storm surge, which was 8.6 feet. So when I say storm tide, it takes into account what was going on at the time, which is that anomaly of 0.8 feet plus the storm surge for a total of 9.4 feet. But at the battery, the area that was flooded, which this is ground level, it was actually 4.72 feet above ground level there. So that's how much storm tide affected the local land event there. I know there's probably a million questions about Sandy, but that was my quick 3-minute version. Anyway, thank you. That's my presentation. Then here's the URL to get to our website, tidesandcurrents.noaa.gov, and there's my contact information. Thank you very much.
Okay, we've got no current questions in that. However, like I said, the information has been up, so anyone who's got questions can send a message to Ed or to anyone else here from NOAA specific to that. And I know there's a lot of people who are considering what to do in case of particularly coastal storm. And we all know the last 3 hurricanes that have struck New York rather fiercely: Irene, which hit a lot of rural areas; Sandy, which hit a lot of the obviously New York City area; and then Superstorm Nemo, also following not far up afterwards. It's got very much visible. So thank you again. That's really relevant to a lot of us here in New York State. Muchly appreciated. All right, Ed, who do we have next?
I believe Adam.
Okay.
So this is Doug too. So you want to? I guess I need to share my desktop.
Yep, I'm getting there. Right. Hold on one sec.
Okay.
All right, Doug, you're being shared in now. And you're on.
Adam hopefully has been taken off mute.
Hold on a second. There, Adam should be off mute now. Sorry about that.
It's okay. Hello, everyone. Can you all hear me?
Yeah.
Okay, great. So in the sake of time, I'm going to fly through some introductory slides. You can go ahead, Doug, and go through to the next slide. So I'm a coastal hazard specialist with NOAA, and this is a graphic that shows the, many of you may be familiar with this. This is from the development of the National Disaster Recovery Framework. I know much of the content thus far has been about our response activities, and I think the decision tools that Doug and I are going to talk about a little bit are more related to some of the preparedness and intermediate and long-term aspects of disaster recovery, not so much short-term. So Doug, next slide.
Sorry, I hit the wrong button. Hang on.
No problem. So the next slide basically shows some of the activities that NOAA is involved in at the Joint Field Offices after implementation of the National Disaster Recovery Framework. So we send staff people to work at the JFOs in both New York and New Jersey and part-time in Connecticut for several months. And our mission there is to primarily support the development of 2 very key documents that pretty much dictate the interagency federal recovery effort in support of the states. So Doug, next slide. So the way the National Disaster Framework is organized is into a set of recovery support functions. They are listed here. Of course, NOAA's mandates and authorities cross several of these. However, there are 2 of them that we are primarily supporting. Doug? And those are the natural and cultural resource recovery support functions and the community planning and capacity building recovery support function. You can read our basically what the mission of those support functions are, and NOAA is a supporting agency to DOI under natural and cultural resources, and supporting to FEMA, who leads the community planning and capacity building. And then the next slide, Doug, shows our key documents, and this is where geospatial technology really came into play, and Doug's going to provide you some really specific examples of that. The first thing that we do under the NDRF within our recovery support functions is to begin developing a mission scoping assessment. This is a living document that attempts to address and assess impacts related to these recovery support functions. So our staff in New York and New Jersey were on the ground working with the states and other organizations to assess impact, gaps of information, and determine the breadth of federal support. The next step, once there's a scoping assessment, that impact assessment process evolves into a recovery support strategy where we attempt to develop a unified strategy for federal resources in support of the state and also tribal, other territorial agencies, organizations, wherever you are. And then, Doug, if you want to go to the next slide, you can maybe talk about how we were able to provide some support in terms of spatial technology into developing both the mission scoping assessment and recovery support strategy for New York and New Jersey.
Yeah, thanks, Adam. Everybody hear me okay?
Hear you fine.
Okay, great. Thanks. This is Doug Marcy. I'm with NOAA Coastal Services Center. Work with Adam, also a coastal hazard specialist, and we supported Sandy activities. Adam was at the Joint Field Office in New Jersey. We also had a person, Sandy Esslinger, at the Joint Field Office in Queens in New York. And in both cases, I'm going to show you some examples here from New York where we basically took some of the data that came out after the post-Sandy assessment, looking at the storm surge footprint. FEMA was able to produce an inundation layer based on high watermark data and some of the initial slosh runs that the Hurricane Center did, and came up with an inundation footprint. We were able to use that as sort of a first cut of what natural and coastal resources were impacted. So we were able to overlay that inundation layer with point layers, such as from the Environmental Sensitivity Index, the ORNR database that they maintain for looking at socioeconomic points. Here's an example of one for Con Edison on 60th Street here. So looking at point data. Here's another one. I just took a couple examples with the inundation footprint on top of some of the National Park Service boundaries. And then another one here looking at significant coastal habitats. So this essentially was an overlay GIS exercise to come up with numbers and acres and that kind of thing to go into this mission scoping assessment that Adam was talking about. So we were able to generate these type of lengths of shoreline, lengths of different types of shoreline that were impacted, you know, from the Environmental Sensitivity Index, and then also looking at, you know, this is just an example, but it's some priority sites from the National Heritage Database and things like that. So again, this is more on the recovery end of things. Another example, kind of going away from the initial products we were doing, but we also worked with the Department of State, the coastal program there. I specifically was working with Jeff Herder to provide some guidance and some mapping on some hazard zones for the guidance for community reconstruction zone plans that just came out. I'll show you some examples here. We're able to produce maps showing extreme, high, and moderate risk zones from different inundation types. And I'll show you the layers that went into that. But essentially, it gives you an idea of going kind of beyond just the 100-year floodplain. There's certainly flood risk that goes beyond that, and we saw some areas, you know, that this was much larger than a 100-year event. So we're using some of the other layers of, such as hurricane evacuation study data, slosh runs, to come up with some of these maps. So we created some map services and the GIS data that went into the guidance report and could be used for reconstruction zone planning. I hope to be able to share the PowerPoint with you guys. I don't know if we're going to be able to do that because these have a lot of links and some of them are really long URLs. But but here's an example of some of the layers that went into that. Like the extreme zone, we used a combination of V zones, Weather Service Coastal Advisory layer that we mapped, susceptible natural shoreline feature that the Department of State has. We looked at sea level rise impacts above mean high water. You see some of the other ones there. So basically taking a combination of these zones and taking the landwardmost.
Yes.
Then I'm going to move on real quick to just some other tools that we have. I hope maybe you're familiar with our digital coast. We have a lot of data on here, including LiDAR data. It's a very popular data set that's used for pre-storm, post-storm analysis. And we have other data sets like land cover data that can be used as well. We also have tools and training. Just an example, we have post-Sandy LiDAR from the Corps of Engineers that's already been flown and processed and put up here. Digital coast that can be downloaded. We're going to be adding more post-Sandy stuff that will be collected with the supplemental money. NGS is going to be, National Geodetic Survey is going to be doing some flying, and we will work to get that data up on here as well. We have other tools on there. For instance, you may have seen our historical hurricane tracks tool. You can use this to determine storm climatology for a particular region. Enter in your geography and look at how many storms have impacted your area. We have working with the group that Adam's currently working with now, National Climatic Data Center in Asheville, that we have all the global tracks in there too. So if you're interested in looking at Japan or some other place, that all the tracks are in there. We have a couple tools on looking at specific county information, like how much of the county, how much of the certain population in the county is in the floodplain, how many critical facilities types that are in the floodplain. We also have some other information on the amount of the county's economy depends on ocean jobs, ocean-related jobs, and also the wetlands benefits. And there's a great site here. It's called, it's the nickname eNow, but it's basically looking at the ocean and the Great Lakes economy in 6 different sectors. You can pull out how much of that state or that county's economy is driven by certain sectors. And that has a lot to do with, what areas are going to be impacted by storms, how resilient will they be able to, how fast will they be able to bounce back. Just a couple, and then I'm done here. A couple more. We have a sea level rise, coastal flood impacts viewer. We just released New York, New Jersey, and New York are both in this viewer now. I don't have time to demo it, but you can check it out. It's just our website /SLR. We basically we map above, starting with mean high or high water. We use the NOAA VDATUM model to get that surface. We map plus 6 feet above mean high or high water to look at the impacts. We've shared some of this data with New Jersey. They have a statewide data site called the New Jersey Flood Mapper, so they're bringing in our data layers, but they're using their own roads and their own critical facilities to show potential vulnerabilities. We've also done some sharing of the data with the New York Mayor's Office, the planning group there. Last thing I'll say is we've been working very closely trying to get a product out. It's been difficult to get it cleared, but we're continuing to try to, the current flood insurance rate maps and the advisory maps that came out after Sandy, don't take into account future risk. They don't take into account sea level rise. So we've been trying to use some of the global sea level rise scenarios and some of the scenarios that the New York Panel on Climate Change have put out to show the horizontal extent of the expansion of the floodplain if sea level were to rise a certain number of feet. So that's a product we're going to still try to get rolled out here in June. And that's all I got.
All right, we do have a couple questions in that regard. That one seems to have piqued the interest of many. Okay. Let's see. General question on slosh. Are there plans to create slosh models for Great Lakes? During Sandy, we were concerned the wave action of the storm might have caused said and had requests for similar products to slosh model.
I am not aware of any development of slosh on the Great Lakes. Okay. If there's a requirement there, I would imagine it would have to come from the weather forecast office that serves that particular lake, and they would make a request to the Hurricane Center for them to try to set something up like that. But I know there's no grids, for instance, model grids on slosh for the Great Lakes right now.
That's something I think certainly coming from my hometown. It's not far from Lake Ontario. I could certainly see where that would be something interesting. And yeah, I know slosh modeling typically takes into account more of the hurricane-affected areas, but when you look at something that's certainly very interesting, and I would probably take your recommendation to the question, or if it was you, Justin, to go ahead and follow through with NOAA on that. Additionally, there was power substations were knocked out, hospital basement flooded as a result of Sandy. What were your post-Sandy assessment say about mitigating such risks in the future?
I'm sorry, repeat, what was the question again, the exact question?
Somebody had mentioned that their power substations were knocked out, hospital basements were flooded, tunnels were flooded as a result of Sandy. What will your post-Sandy assessment say about mitigating these risks in the future?
Yeah, that's a good question. The NOAA, well, the National, the Weather Service assessment just came out, and there's a lot of recommendations in there that are, they've been the same, a lot of the same recommendations we've had. Part of it is what Darren just talked about, is how we communicate water level forecasts, and there's confusion with datums, and giving people information height above ground so they know exactly, if they know, okay, in this particular power substation you're going to have 2 or 3 feet of water, they could start figuring out if those are going to have problems and shut them down in advance. And, you know, part of the type of tools and things we've been working on in post-Sandy recovery is to try to take into account some of these, you know, impacts of climate change, for instance, and if there is going to be bigger storms or with sea level rise on top, you know, what is the freeboard we need to be building to, you know, adding to 1 or 2 feet above additional additional freeboard above our existing structures so that we can be a little bit more resilient to the next go-around of storms. So that's something that it's the first time, for instance, the community block development grants from HUD have come out. You know, there's a stipulation in there that you have to build back to the advisory-based flood elevation plus 1 foot. So at least takes into account a 1 foot of freeboard. But those type of initiatives are going to hopefully help with that, with the mitigation. And then there's, of course, mitigation grant funding that requires, you know, a state or a county, whatever, to have a mitigation grant. I mean, hazard mitigation plan, and then, you know, of course, they can apply for grant money to try to retrofit structures and whatnot.
Yeah, and that's a great point. I would stress to a lot of people, you know, it's not just New York City. You know, obviously disasters hit everything from large to medium to small areas. Having a good plan in place, having the right people to help execute that plan, can really make all the difference in the world. So I actively encourage anyone representing a state or local government in a way to work together to get a good plan, be it for tornadoes or hurricanes or whatever, and be sure to keep it updated and relevant and workable, and keep a good stakeholder group together. I find that a good stakeholder group locally or statewide really can improve the ability to react in times like this. So great point. Let's see. I believe, Gary, you're up next.
Yes, I'm here.
All right, switching to you as presenter.
Okay, let me know if you can see my screen.
Second. Did we lose Gary? Sorry about that. Go ahead, Gary.
Gary, if you're talking, we don't hear you.
He's up, and let me check. He's not self-muted. Having trouble, maybe Gary trouble with it. Let us know if you're on the line here, Gary. Gary, we see your screen. We don't hear you yet.
It looks like he's trying to call. He's going to need a PIN number, right?
Well, he's already had his PIN number, and he's not muted. Oh, all right. Hold on. Let me send him I'm sending him another audio PIN. All right. All right, Gary. You should have you on now.
Can you hear me?
Yes. Now we can hear you.
Okay. I just tried again with the audio pin, so I hung up and redialed.
Okay. That explains it. When you hung up and redialed. All right.
Okay.
No problem. We're good to go.
And my screen is showing?
Yes, it is.
Okay, excellent. Sorry for the technical snafu. Okay, my presentation is going to be a little bit broader in scope and not Sandy specific. I'll provide you with a brief overview, a little bit about the forecast services that we provide, talk a little bit about the decision support services, as well as communicating our information. And so, mission of the Weather Service, I just put it up here so that you can see. And the challenge that we have is we are one of 122 weather forecast offices across the country, located here on Long Island, New York, and we have to coordinate and collaborate all of our forecasts depending upon what specific hazards and the potential impacts that they might produce. So during Sandy, for example, we actually had to coordinate our forecast through the National Hurricane Center, the Storm Prediction Center, Weather Prediction Center, River Forecast Centers, and surrounding weather forecast offices to ensure that we have collaborated and our forecasts result in basically geographical compatible forecasts. And so the big difference here between the individual weather forecast offices and the national centers is that we basically know our local area. We know about the day-to-day weather changes, the climate that takes place. We know our microclimates and so forth. And so we're here to essentially use a different set of tools to deliver higher detailed and more specific forecasts. And if we go sort of to the gospel, and I took this, I guess, right from the title of our products and services, we do have some links that provide you with a detailed laundry list of all of the products and services that we use and how we basically can communicate, or how we do communicate, those services. So I have some links here. I'm hoping that the presentation will be shared for you to use it, but just a quick snapshot where we do have these links under the NWS Product and Services Reference Guidebook, as well as the different communication channels that are currently used, and there's quite a few, Our service area is basically shown, small but challenging, as you might guess. That's a picture of our forecast office, and we're at about 65 miles east of New York City, and the staff, 21 meteorologists and 5 technicians. An example of our operations room, and some of the technology that we use so that you can basically see what an advanced weather interactive processing workstation actually looks like. And I would be remiss if I didn't include, I'm the warning coordination meteorologist, so we like to talk about outlooks, watches, and warnings, what forecast confidence is, and what they actually mean. But we use a multi-tiered approach, basically, on the simple principle of get ready, get set, and go. And warnings, as you know, are life-threatening. Advisories are a little bit less serious. Now, on the day-to-day forecast, the WFOs, or Weather Forecast Offices, specialize in producing 7-day forecasts using a national digital forecast database. The smallest area that we forecast for is a 2.5-kilometer grid, and it's within that geographic domain that I basically just showed. And from that 7-day forecast, we typically have 2 forecasters in it. One that produces enhanced short-term forecasts, first 36 hours of a weather forecast that is updated on a rolling 3-hour basis. And then we have a long-range forecaster who takes it from 36 hours out through 7 days. And from this set of data, and it's very detailed, we then generate a set of graphics, tabular, and text forecasts. So our main centerpiece is the National Digital Forecast Database for all of our routine products that are available in grid format, in XML, RSS data feeds. And so this is not where we are actually producing the warnings, but this is where you can actually get access to our hourly forecasts of temperature, dew point temperature, wind direction, wind speed. This is where we generate the spot forecast for a variety of different purposes, whether it's a prescribed fire burn or any other thing that basically comes up. It's through our National Digital Forecast Database. And we basically we instant message our forecast teams from the offices surrounding us. So here in Long Island, New York, we work closely with the Philadelphia office in Mount Holly, with the Binghamton office just to our northwest, with the Albany Weather Forecast office to our north, and with the Taunton, Massachusetts office that services Boston to our northeast. And our pieces basically are used to produce. This is just one example of a graphical forecast that shows the maximum temperature forecast a little bit earlier this week. This was on Monday, May the 20th. So it's just a sample of the graphic forecasts that we produce out of our National Digital Forecast Database, now taken down to the local level. And we produce quick forecasts. This is an example for Islip, New York, and the forecast is basically based on this little red square, which is a 2.5-kilometer square, that then generates all of the tabular information and all of the hourly information for that specific location. You can input selected geographic locations. You can input selected latitude, longitude coordinates. And so you can basically generate a set, and here this is a 7-day set of forecasts that can be displayed within a 48-hour time frame of the time that you select, and it's all selectable. So if you only want the temperature, the dew point temperature, if you only want the surface winds, you only need to select those locations before you submit the job, and you will get essentially the hourly forecast for temperature, dew point, wind speed, and wind direction for the 48 hours that you selected. Point-and-click forecasts, more similar again to the general public. Again, just for comparative purposes, I do have the 2.5-kilometer grid box up here, again, basically showing essentially in a television type of format, point and click. We use the icons that basically characterize the weather forecast for the day, and the details are actually in the text product beneath it. Text forecasts, I think you all are aware of the text forecasts, and I did put this in here, other forecasts, hydrology and aviation, and we do have, again, if you go back to Sandy, and Sandy is just one of many, many different examples, but we are working very, very closely with the National Hurricane Center in collaborating the storm surge forecast that we basically place in ranges to indicate forecast uncertainty, but this is what occurred through our advanced hydrologic predictive service at the battery at a specific location. So not only the forecasts are that way, but the observations are there as well, both in text and graphic format. And here's an example of hourly observations that were taken earlier this week at Central Park that are decoded. This was on the 20th of May. The time here is in Eastern Daylight Time, and you can take a look at the winds, visibility, the weather, the sky conditions, quite a bit of detail actually provided. That's in text for any potential RSS feeds. The other method that we use is that text can then be converted into graphics, which we call mediograms. And they can go back and they can provide you here with what did occur over the past 3 days in graphic format when we take a look at hourly temperatures, dew point temperatures, humidity, and so forth. So this is to give you, in case you didn't know, some of the services that we provide out of our National Digital Forecast database that is outside of the outlooks, the watches, and the warnings that we typically produce. And in addition to our forecast team producing these web-based products, as some of you know, we also provide email services. We actually draft presentations, and these presentations basically make it simple for our emergency managers, for our media partners, to basically discern and get that clear and unified message so that we can basically ask whether it's the media spreading the word or whether it's our emergency managers who need the consolidated information to help them act more quickly. We can put it in informational emails and electronic presentations. And when we're talking about potential high-impact events, we actually give webinars similar to the one that you're on right now, where we basically consolidate all of the information that could produce high-impact events. Just a quick example of an email that I first sent out, and I think most of us will remember Monday, October the 29th, and our first emails went out about 6 days in advance, and this is just a sample of one that I sent to our local emergency managers within New York, New Jersey, and Connecticut, just to grab their attention for situational awareness. And here's an example of some of the graphics that we typically will use working with the National Hurricane Center, again, during what we call the threat phase, days 3 through 5, again, to grab people's attention to the potential of impacts that could be caused by Sandy, initially with the tropical storm force winds, and what those probabilities mean. And communicating our services. just a variety of different ways that we communicate our services. Through the internet, we have a page for the emergency managers. I realize that many of you folks work with the emergency managers, so we have customized an emergency managers page. We do use social media as taking on a much more significant role here at the office. As a matter of fact, during Sandy, it was using Twitter. Twitter is how we got a lot of the photographs and meaningful information. And for those people that have their new phone, their latest phones, the wireless emergency alerts have actually been in operation for a while. And so now when we issue flash flood warnings, people are getting them on the phone. And that's a great thing. Facebook and Twitter, just an example of our Facebook page, but a couple of the posts that we had actually from Sandy. Twitter, and these are the pictures that we received, Lower Manhattan, Coney Island, and this was during real time when we were forecasting so that we could maintain our situational awareness for the area that we serve as well. And different types of platforms that are available to actually receive the information. The CMAS is actually Commercial Mobile Alerting System, but WIA for short, Wireless Emergency Alerts, and those have been, that was implemented back on June of, I want to say, 2012, about a year ago. And we issue hurricane watches, hurricane warnings, tropical storm watches and warnings, blizzard warnings, tornado warnings, flash flood warnings. They are all carried on the wireless emergency alerts, thanks to the efforts at our national headquarters in Silver Spring in working with the cell contractors to make this happen, which has been great. And here's just a review of some of the warnings that are actually carried on those wireless emergency alerts. And just wanted to give you a couple of contacts. Ross Dickman, who's sitting next to me, is our meteorologist in charge. And if you need us for any type of information, we've got our email there along with some telephone numbers. And I'm the local warning coordination meteorologist. I basically serve as our local customer service representative. And we work with so many different groups, from emergency managers to mariners, to aviators, to fire weather folks. And we do have Nancy Furbish is actually our GIS team leader. So we were very fortunate to actually have a class that CSC, the Coastal Services Center, just put on at the New York City Office of Emergency Management in Brooklyn, New York. So we are very, very grateful, and we are basically beginning to hone some of our own GIS skills so that we can deliver some improved products that are needed. Okay, that's all I have.
Gary, thank you. I just want to make a quick note. First of all, I do follow, and I highly recommend those of you who are on Twitter to follow NOAA, also the 511 for New York. Both of them provide very valuable weather and other kinds of alerts, and I think that service should be known about. It's absolutely excellent. Also, for our colleagues in Oklahoma, certainly you could also follow along with yours. You know, look it up there for your or searching on Twitter. That both are good. Also, in addition, a lot of the pictures that you saw, that sort of ground truthing situation, as it were, just as happening, that really does help a lot of us in emergency responses. We had real-time gas information that worked together with FEMA and Gas Buddy and AAA and a lot of other sources for that. That ground truthing can really help people make good decisions in an emergency. So used properly and kind of put together with the people who are putting together authoritative sort of instant information, ground truthing and Twitter can really serve a very broad audience. I know sometimes it's difficult getting signal in emergencies because a lot of people are on their phones for various and sundry emergency purposes, but if you can, or you can get information, or if you're out of the emergency area but you can get information for people to it somehow safely, then that works as well. Gary, greatly appreciated. Thank you.
Okay, thank you.
Welcome. And if I'm not mistaken, We have the last one here. Brent, I believe you're next. So I'm going to switch it over to Brent. Okay, Brent, I've just switched it over to you.
All right, and see my PowerPoint there?
It should be coming up momentarily. It hasn't popped up yet. Should be an option to share your screen. There we go.
Okay.
Just popped up.
All right. So I'm Brent Pounds. I'm the navigation manager for the Northeast region, working for the Office of Coast Survey, and I'll kind of get into what a navigation manager does later in my presentation. But I'm going to kind of give an overview of the Office of Coast Survey's role and responsibility, and particularly our emergency response capabilities in this presentation. So I want to start out with kind of a general overview of the Coast Survey and background information. Coast Survey was created in 1807 to basically conduct surveys for all U.S. waters for safety of shipping, and that remains our mission today. We are responsible for surveying over 3.4 million square nautical miles of U.S. territorial waters, and maintaining a suite of over 1,000 nautical charts for the safety of navigation. And part of that emergency response to speed the resumption of port operations following a natural or man-made disaster. We have a variety of products and services available. As I said, we have over 1,000 nautical charts available in traditional lithographic paper print, as well as raster electronic charts. Those raster charts are essentially just a geo-referenced image of the paper chart, and those are available for free download from our website. We also maintain almost 1,000 electronic nautical charts, or ENCs, and those are a vectorized product, so they scale appropriately at different zoom levels, and also contain additional information about point features and lines that you can use. And those are also available free for download from our website. We make over 1,000 of our charts available on a print-on-demand basis through a contract with Oceanographic, and those are printed at the time of purchase, so they're updated with all the appropriate information, whereas the traditional print would have to be updated after purchase. We also maintain the Coast Pilots, which is supplemental information to the nautical chart. It contains a bunch of information like how to contact pilots, port services, anchorage, holding ground, etc. that's difficult to portray on the chart. So it's really an additional information to the nautical chart. We have several products geared more towards recreational boaters, including the pocket chart and booklet chart. Both are the charts basically shrunk down to a more usable size for small boats. And we also just within the last week rolled out a beta version of a new application called My NOAA Charts. And that's going to allow users to download a free app to their Android tablet or phone and be able to view NOAA raster charts as well as pull up information from the Coast Pilot. All of those products are updated weekly with Notice to Mariners corrections and out electronically, as well as the Notice to Mariners corrections for manual correction on the print products. This brings me to kind of our emergency response capabilities. And the first kind of thing to note is as the Office of Coast Survey is set up really well for regionalized emergency response. And one of the main assets that we have there are the regional navigation managers. We have 12 regions defined throughout the country. Each one has an individual navigation manager. As I said, I'm the Northeast navigation manager, so I work on the coast from New Jersey all the way up to Eastport, Maine. And we're really the face of the Office of Coast Survey, working with port partners. I jokingly say that my job is professional meeting attender because I tend to go back and forth between different Harbor Safety Committee meetings all up and down through my area, including the Harbor Operations Committee meetings in the Port of New York and New Jersey. These meetings really allow the navigation manager to develop working relationships with the Coast Guard, the pilots, port authorities, and all the other port partners that we work with daily to ensure that NOAA navigation products and services are meeting the needs of the port, and also coordinate future survey operations to address any problems. In the event of an emergency response, these navigation managers are embedded within the Coast Guard's Marine Transportation System Recovery Unit, or MTSRU, and they work to coordinate NOAA's response post-storm or with Coast Guard needs, port partner needs, as well as coordinating our operations with the Army Corps of Engineers that also conducts emergency survey work after a major event. We have several assets that we can call on for emergency response survey work. The most readily available are our regional navigation response teams. We have 6 of those teams located throughout the country. They're highly mobile units, and they're easily deployed within their region. The goal is for them to be able to respond to an emergency within 24 hours following deployment. And those teams work extensively with the navigation managers and also work on regular projects, so they're an operational unit and can be pulled off those projects supporting basic chart updating work to do both emergency and non-emergency response work. The teams are comprised of about 3 highly specialized hydrographers that can operate the boat and run acquisition systems and then process the data they acquire. They have a 30-foot trailerable survey launch that's equipped with a highly accurate GPS and inertial motion positioning system and multi-beam and single-beam sonars. They also have an office trailer that is equipped with data processing computers and auxiliary power, so they can pretty much set up completely dependent of additional support from the local infrastructure following a disaster. Another option we have are our mobile integrated survey teams, or MIST. I think we have 2 of these kits available currently, and they're kind of a flyaway hydrographic survey system. So they incorporate the acquisition and processing computers, a GPS positioning system, a single beam sonar, and a side scan sonar that can either be towed or hull mounted depending on the vessel it's set up on. These rely on a vessel of opportunity, and in general they're not our first option for emergency response given the time that's necessary to set the system up on a vessel of opportunity. Generally that pulls a lot more resources out in the first few days to get those set up and also get them working, because you have more chance of having technical difficulties setting up a system on an unknown vessel. The NRTs are an operational platform, so pretty much when they arrive they can splash and go. We also have our fleet of hydrographic survey ships, 2 of which are on the East Coast, the NOAA ship Thomas Jefferson and the NOAA ship Ferdinand Hassler. We also have the Bay Hydro 2, which is more of a research and development platform that doesn't operate much outside the mid-Atlantic region. But the Thomas Jefferson and Hassler could be pulled in for emergency operations if they're operating in the region and can be deployed to that spot within a reasonable time frame. But in general, they're going to be slower to get to a response effort than either the NRTs or the MIST. We also have the option of bringing in contractors already under contract with NOAA. So if we have contract survey work going on in the port, we can do an emergency task order to transition their operations to emergency response instead of the contract work that they were doing. But if we don't have a contractor already under contract, the process usually takes too long to get them set up immediately to do that immediate storm response work. Though we are using contractors in the case of Hurricane Sandy for a lot of the supplemental survey work that's going to be going on in New York Harbor. All of that's going to be done by contractors later this year. With that, I'm going to basically touch on the Hurricane Sandy work that was done last year, as that's kind of the biggest navigation event we've had in recent history. The Port of New York was shut down at the outset of Hurricane Sandy for obvious reasons. And then prior to reopening the waterways, it became evident that a full survey of the navigational channels had to be completed in order to ensure the safety of the vessels moving into the port. The navigation managers, myself and my counterpart from the southeast region, were embedded with the Coast Guard's MITSRU on Staten Island and kind of coordinated both the NOAA survey response and worked heavily with the Army Corps of Engineers on their survey assets and work. I should note that the Army Corps has a significant survey presence within the Port of New York and New Jersey, based out of Caven Point. That facility was almost completely wiped out in Hurricane Sandy. All of their processing capacity, as well as their vertical and horizontal reference stations, were destroyed. So their processing capability was hindered. They also, due to the nature of their work, using side scan and in the efficient, so we were able to cover greater rest almost that we start putting out as soon as we get into the rapid maritime response framework, as soon as we see that a storm event has potential impact to a major port. It basically communicates the location and status of our available survey assets for response work. This graphic was the day after Hurricane Sandy had made landfall. As you can see, NRT-5 has already been deployed to the Port of New York and New Jersey. NRT-2, which was already mobilized up the I-95 corridor, was directed to continue to the Port of New York and New Jersey. And the NOAA ship Thomas Jefferson was pulled off their project in Long Island Sound to provide additional survey support in the port. This is basically a picture of what we were working off of during Hurricane Sandy. This was a chart we printed off and posted in the MITSRU. And as we coordinated with the Army Corps and NOAA assets, they'd basically survey an area and look for major obstructions or significant shoaling. If they didn't find anything, they just give us a verbal communication back that the area was clear, and we'd color it in with a green marker. And almost before we finished coloring in, the captain of the port would open that waterway. And the screen to the left is from the Coast Guard Home Ports website and gives the status of each waterway. And as we finished survey work, they just changed that status to open or open with restrictions in the case of areas that were restricted to draft because significant shoaling or objects, or in this case, the oil spill in the Arthur Kill. These are some of the products that we produced during Hurricane Sandy. The one on the left is the basically the electronic version of that chart on the wall, and it shows areas that had been surveyed and cleared. And this is a product I think we're going to move forward with in future responses, provide this to the Coast Guard for dissemination on their home port, just as a good communication tool to the shipping industry, pilots, and others looking to home port to see what areas have been surveyed and cleared, and that's a kind of a quick reference. We also produce sounding plots and DTMs, or digital terrain models, using multibeam. The one on top there was a quick one at Sandy Point. The tip of Sandy Point, or Sandy Hook rather, progressed north into the channel. We did a quick color coding. Green was project depth for the channel. Red showed depth shoaler than that. And we also portrayed the individual dense sounding plot in that area, because the pilots like to see the depths they're working with. Once we did further processing, we're able to produce something like the image on the bottom, and that's a geo-referenced PDF image. It incorporates several charts, digital terrain models, side scan mosaics, and sounding layers, and each one is a layer that can be turned on and off, and it's a pretty easily used format. Being an Adobe product, most people have Adobe readers on their computers. In general, our operations are to do 100% side scan with concurrent multi-beam or single beam. The multi-beam and single beam provide depth. The side scan provides object detection between those lines of depth. And any wrecks or obstructions that are noted in the side scan get revisited with multi-beam to determine least depth and get a more accurate position on those. Our side scan mosaics and multi-beam data is all pushed to the National Geophysical Data Center and made available through their web portal. And I'll kind of skip over this slide. Most people are aware of how important the Port of New York is in all of our ports, but that's why we place a heavy emphasis on being able to do this emergency response work in order to minimize impact on the marine transportation system and ensure that commerce begins flowing as quickly as possible after a major event. And with that, I can take any questions, and those are the two web links, both to our website, nauticalcharts.noaa.gov, where all of our products and services are available, and the NGDC, or National Geophysical Data website, or Data Center website, where you can download our products, our DTMs and survey products.
Okay, thanks. We have a couple questions. Actually got three right here. And this can go to just about everyone here at NOAA. When you brief regional EOC managers about events, are you aware of whether EOC GIS managers are included? And that can go broadly to all the people at NOAA.
This is Gary Conti here. We do actually, we are aware of the fact that the GIS team, working with the emergency managers, do participate. And at a variety of different levels, actually, when we provide briefings within their EOC. And just as a matter of fact, it was earlier this month that we actually offered a three-day hurricane course where the National Hurricane Center came up and basically led, and we co-instructed units, and the GIS teams were represented essentially from New York City OEM and Nassau County, and I think there was even representation from Rockland County.
Okay, excellent. Next question. Do you have some new standard observed products for something like Sandy or other events like Irene and Lee, like cumulative rainfall over an event, or max incurred wind observed over a 24-hour period, and most importantly, for us skiers, as was noted, cumulative snowfall over an entire event?
Wow. Gary Conti again. We do work, you know, each of the weather forecast offices have their own area of responsibility. And I think I showed you the area that we serve. It did include New York City, Northeast New Jersey, Long Island, and Southern Connecticut. But I think essentially our river forecast centers do a mosaic across broader areas that will actually show, for example, what the regional storm total rainfall was. Now, in Sandy, I know you probably have to go further southern New Jersey, Maryland, Delaware, Washington, D.C., it was to the left of the track. And I do believe that there are graphics that actually, do show that. So different parts of the organization in the Weather Service do produce that information, but they typically, the Weather Forecast Office that's assigned to a specific area produces information for that area. And it's up to the regional and national centers to provide the regional and national pictures.
Excellent. Thank you very much. I believe the last person on here is John Sellers. John, if you're ready, I'm going to make you the presenter.
Okay, can you hear me?
I can.
All right. Can you see my screen?
Yes, we can see your screen.
Okay.
NOAA's capabilities for image delivery during an emergency response?
No, oh, yeah, that's it.
All right, cool.
So, thank you. I am John Sellers. Mark would actually doing this for Mike. He got called away, and Jason put the majority of this presentation together, so I have to give them all credit, and I thank you for attending. We work at the National Geodetic Survey, which is part of the National Ocean Service within NOAA. And my colleagues have kind of touched on, why we do this and how it fits into kind of the broader picture, and touched a little bit on the coordination. One of the things that I think is really important about the imagery that we collect is that once we post it, it is public domain, and therefore other agencies can use it, the public can use it, they can download it, view it, value add it, do damage analysis, etc., and there's no licensing issues. And during an event, our primary goal is to get that data out as quickly as possible and to make sure that it is as accurate as possible. To do that, we have several aircraft that we can install the camera systems in. During Sandy, the primary assets were the King Air and the Twin Otter. Our cameras are twin 39 megapixel cameras, which give us RGB and near-infrared capability. To turn around quickly, we have an integrated GPS system with an IMU, which tags each image with not only the location of where the image was taken, but where the camera was pointing when the image was taken, which allows us to push that image down to the ground and georeference it. So pretty much nothing during Sandy was a typical mission profile. Very seldom were we able to get up to 7,500 feet because of the low cloud deck. Typically we were flying down around 2,000 feet to get under the clouds and acquire imagery, which gave us a higher ground sample distance, but it gave us a lot more images to process and slowed down the processing a little bit. As far as the processing, we have a kind of a hybrid workflow. We have some open source components and some kind of proprietary manufacturer components. We've come up with this workflow over a lot of years of doing this, and this is working really well for us right now. So in the pre-processing steps, to do image manipulation, we use the GDAL library extensively, and Python as a scripting language to wrap around GDAL and make it do the things we want it to do. To look at the imagery, to do the analysis, to check the accuracy, we use quantum GIS. It also allows us to kind of look at the areas that we have collected data, where do we need to collect data, and to some degree select data to distribute for processing in different processing nodes. The camera, the Aplanix system, we can land with developed JPEGs, which puts us ahead of the game as far as processing. Those are uploaded via 4G modem to us, where we combine the GPS and IMU data for each image, apply that to the imagery using the awesome library as the open source software for image manipulation. And what that does is it takes the GPS IMU information for that image and pushes it down to the ground using the USGS NED data as the elevation source. We then take all of the images and stitch them together into a seamless mosaic using info. And then on the web delivery end of that, we are again using GDAL, Python to process the imagery, with GeoEXT and open layers to deliver the imagery, and then to make the data available to a multitude of devices, we use tile server PHP on the server side to deliver the data. So during an event, we typically do not deliver right away the near-infrared imagery, so we're primarily delivering the RGB imagery at 35 centimeter resolution in 2.5 kilometer tiles. The data are in geographic lat-long projection in NAD83. So as far as the products, we have web viewers, so you can see the data in a browser. You can look at the coverage of the data using KML and where we have flown in KML, and then for each of the days, the ability to download all of the imagery by day with the metadata. And if you want to, or you can bring the data into your GIS through a web mapping tile service, and that's being all delivered by tile server. We do have the data available on mobile devices as tiles, some other general information, which I'll actually show in a couple of slides. And then at the same time, we're making all of this data available to the Google Crisis Map using their manifest file, an EBM file. This is a screen grab from the Hurricane Sandy response. So this is a live map. You can zoom in, pan around, turn layers on and off. If you select kind of the Google Maps layer or the imagery layer as a base map, you can do before-after image analysis, basically in the browser by sliding the image transparency slider back and forth. On mobile devices, we've developed a mobile web app using Centric, which is another open source tool, which allows us to deliver the data to all mobile devices, regardless of Android, iOS, etc., from a single application. Within the mobile application, you can select a particular day, click on the day, and you'll be able to see the imagery from that day. And down here at the bottom, this is, again, a little slider bar, so you can do before-after imagery analysis on your phone. And some of the additional data that we deliver through the mobile device would be the hurricane track and then the areas that we have flown. So this is kind of a little bit of background on tile server. That's what allows us to kind of deliver the data to all these devices from a single tile source. It is an open source project that was actually initially developed in-house by Jason Willard and myself. One of the nice things about it is that you only need Apache and PHP on the back end to deliver the data to all of these different devices, browsers, GIS. And it's being delivered in the open standards of WMTS and TMS. And probably of interest to the GIS users is that it works in your GIS and with Quantum GIS or ArcGIS. This is a screen grab of the WMTS being displayed in Quantum GIS over an OpenStreetMap base map. It does work in Quantum at 1.9 and up, and natively in ArcMap 10.1 and plus, and from 9.31 and up if you're using the ArcBrew tile extension. So the primary users of the data are FEMA, the different emergency management agencies, different DOTs, and the public, being able to look when you're displaced from an event like this, the ability to, on your phone, find imagery of your neighborhood to see what has happened when you can't be there is very important. And Sandy was a really large response, 18 flights in 7 days, so it was a very busy period for us. This is a derivative product. As I was mentioning, since the data are public domain, FEMA was able to contract out the ability to do damage assessments from the imagery, and the products delivered by, I believe it was ImageCat, and it shows the level of damage at different locations. We then took that data and made a mashup, kind of a heat map of the damage in the impact area. This is our website where all of the storms that we have flown and everything that we will fly will be at this address. If you can go to this URL, you can see what we have done in the past. You can also see where we started at back in Hurricane Isabel in 2003 and look at the progress of how we've delivered the data differently over the different time periods. And if you have any questions, you can contact me. My email address is on the screen. And that is it.
John, thank you very much. Let me just quickly see if we got some any questions here. Let's see. We got a few here. Can you show the first slide again with the storm surge wave and the file location of that?
That one? Or the first slide with the
storm surge wave. Yeah, it came in late, so I'm not sure if that was yours or if that was a prior presenter. I apologize. That one just got in.
And that sounds like one of the ones where they had the tide gauge up and showed the different levels or something.
Yep, it's probably a tide gauge one. I believe, Dennis, that was you that asked that. We'll probably have it, we'll probably have that available at some point by when we have the recording. And we'll have this one recorded. You can get it from there. Next question, is QGIS an open source GIS software?
Yes, it is.
Yes, it is. That's what I thought. Thank you. Appreciate that one. I had an exclamation that NOAA rocks.
Well, thank you.
There you go, guys. There's some praise.
I think that one was for us.
Yeah.
I would like to, on the previous point, we've tried to make as much of the workflow open source as possible, not only on the processing end, but on the delivery end. Because, things happen, and it's nice to be able to install your operating system, download a couple of packages, and be back up and running.
Good point. Next one. Can you download the images from your site doing analysis in an image analysis software such as ERDAS engine?
If ARNS supports WMTS, you can access it that way. If they aren't supporting that open standard yet, you can also download the imagery. And if you go to our URL and get into the Sandy map, you'll have the ability, actually, you can still see my screen, right?
Yep.
Okay. Well, hold on.
And then on the prior question, someone wants to see what was slide 4 after you're done with this.
4. All right. So you can download all of the data. Bulk image download, that would be everything flown on a particular day. You can download one image, like this tile, you can download through the link to full resolution image, and then you can download the world files for the imagery through these links, either all of them or an individual world file. And then that will give you the ability to bring the JPEG and world file into any software. And slide 4.
Yep.
That one?
Yep, apparently. Okay, cool. Next one, do you do inland flights during emergency responses?
Inland, like interior of the country, or some distance inland? And the answer to both questions will be yes. We have flown tornadoes. We flew the Tuscaloosa, Birmingham, also Joplin tornadoes. Mm-hmm. We have flown flooding events in North Dakota, and then we try to get as far inland as needed during a hurricane event. A lot of our taskings, though, are coming from from FEMA and other agencies, and so we followed their request on that.
Hey, John, this is Ed. Hopefully you can hear me. Could you just mention about LIDAR? I don't think you mentioned it on your slides.
Yes, we have collected LIDAR after storms in the past. That's not one of our normal product suites. The USGS and the Army Corps of Engineers are very often out after storms flying LIDAR to do, the Army Corps is looking at where is the sand now. The USGS is looking at dune morphology, beach morphology, how these storms impact the beach.
Okay.
Does that,
and a couple of combo. Oh, I'm sorry. Go ahead. Someone else trying to chime in.
no, I was just going to ask if that covered the question. The LIDAR is being collected, and actually there's a lot of LIDAR being collected post-Sandy, so that they should be coming available soon.
Thank
and
you.
then what's the app name for the Android app that was talked about?
Well, we have a web app. So once you get to our site, down here on the bottom, you'll see. Actually, if you navigate to our site on a mobile device, you'll be automatically redirected to the mobile site.
Okay, so it's a mobile site, not a mobile app. All right.
So whether or not you're on Android, iOS, tablets, but they will all work at that site.
And then just as related, could you pop up your contact information again?
Sure thing.
And then because we're going over, I'm going to make this the last question. Do you plan to have LIDAR equipment yourself in the future, or are you going to keep that contracted?
We do own LIDAR equipment.
Okay.
We're typically not deployed for post-storm events.
With that, I'm going to stop the questions at that point. Thank you very much. I know, Ed, you have one last thing, and then I'll take us out.
Thanks. Yeah, I just really wanted to thank you and especially all the presenters for an excellent job. Hopefully the audience learned about the breadth of NOAA's roles. I think we touched on everything from the surface to the bottom of the ocean to aircraft and satellite imagery. And I know, believe it or not, I've learned a few things that I didn't know. Hopefully the other presenters learned from each of the other presenters. And just please feel free to contact us or dig further into our websites. There's a lot there, and I know we really only scratched the surface. So again, thank you, Rich, very much for this opportunity.
Well, thank you. I mean, certainly what was, but it was quite the amazing. I learned a great deal from this, and I'm pretty sure I speak for anyone else who attended that there was a great deal of information. Alan Leitner, do you have anything you want to add before I take us out?
No, I'm just overawed with the capabilities, and I learned tons, and I really appreciate NOAA, Ed, you, and NOAA doing this, and Rich, thanks so much for putting it together.
I think we need to somehow get the taxpayers to understand all this too.
Yeah, it's amazing. I think sometimes if we can just, I think that one of the big challenges we all have in GIS is to take the technicalese that we all know and love and boil it down into something that the taxpayers can understand, not by saying it's not on their level, but in regards that if you have a number of very smart taxpayers in other things. You could be talking to accountants who have no interest per se in GIS. They just want to know how it affects their lives and the weather patterns, and they're perfectly intelligent, but may not all understand our technicalese. So getting that, I guess that's actually a skill or talent, as it were, is to make sure we take some of our cool stuff and make it more accessible to the public. For the benefit of everyone, this I will be, as soon as I get the recording link, we will put it up on the GIS New York site, and I will also forward it to the GIS New York, both the website and our email list, GISNY-L, and I will also post this to the Oklahoma site. Again, our prayers and well wishes to the people in Oklahoma who've been affected by the tornado. For those of you who came in a little late, that was an F5 tornado with winds up to 210 miles per hour that struck down. The images are horrible to behold, and yet hopefully we'll be able to contribute in some small way to some of that alleviation. And all the people here who are on from the state of New York are 150% with you and our thoughts at this time. I'll continue to be on the Oklahoma list as well. Again, thanks everyone for attending. I greatly appreciate your attendance. I know we went over long by a little while, but I thought the information on the ground we covered was really valuable. So my thanks again to New York State GIS Association for helping me out with this, and certainly to NOAA. Their expertise was amazing, and I wish you all a very good day. All right, take care, everyone. Bye-bye. Bye.
The organizer has